Welcome to qnawire.
What's up, StatCats? In this video, we are given some raw data and we are asked to perform a one-way ANOVA. And if that ANOVA test is significant, we are asked to then perform either a Scheffé or a Tukey test. So we are given this raw data, and this is weekly ER visits between different hospitals. So in order to perform an ANOVA, I'm going to be using the data analysis package on Excel, which is also what the book uses. So we're going to do ANOVA single factor, and our input range is going to be all of our data. And we do have labels in the first row, so make sure that's checked. We are doing this at a 0.05 alpha level, so make sure that coincides with what kind of test you're doing. And then our output range is just where it's going to summarize those results for us. So this is the results of our one-way ANOVA test. And what we really want to look at is our critical value and our test statistic. So we will have a significant result if our test value is larger than our critical value. So is 3.76 larger than 3.68? Yes, it is. So we can reject our null hypothesis. So to summarize our results, we would say there is enough evidence to conclude that there is at least one mean that is different from another mean. So because we have a significant ANOVA test, we can go ahead and perform a post hoc test. And if you look, our sample sizes are equal, so we are going to be doing a Tukey test. And the test statistic for this test is found by taking the mean differences and dividing that by the square root of our mean square within groups multiplied by, div, and then we're going to divide that by n. And then our critical value is found with the n table. So let's go back to our Excel spreadsheet so we can do some calculations. So let's do our pairs first. So we're going to pair x and y, y and z, and z and x. So let's take the mean difference. So we're going to take mean difference of x and y and z and x. And then we are going to take the square root of our mean square within groups divided by our sample size, which is all 6. All right, and then we can calculate our test statistic by taking our numerator divided by our denominator. Okay, so these are our test statistics. Notice that one of them is negative, but an F value is always going to be positive, so we can just ignore that and just consider it a positive value. So to find the critical value, we are going to go to our n table, So K is the number of means we have, which is 3. So we have 3 categories. We have hospital X, Y, and Z. And V is our total population, so the sample size, all of our sample sizes together, so 6 times 3, and we're going to subtract K from that. So we're going to take 18 minus 3, so that's going to be 15. So K is 3 and V is 15. So 3.67 is our critical value. All right, let's go to our whiteboard so we can write this down. All right, so in order to figure out if we have a significant pair or not, we're going to see if our test statistic is larger than our critical value. So is 1.77 larger than 3.67? No. Is 2.10? No. Is 3.87? Yes. So we have one significant pair. It's between hospitals X and Z. So there is sufficient evidence to claim that a mean difference exists between pair 3 and 1. All right, that's it for this video, you guys. I hope you learned a lot, and I'll see you next time.